Good afternoon. I'm Jorge Esparza, a research fellow of the Emerging Technologies Institute at the National Defense Industrial Association. On behalf of Arun Serafin, the Executive Director of ETI, I want to thank all attendees for your support of NDIA and ETI, and for joining us today on today's webinar, Trustworthy AI 101 with Dr. Matt Hale. The webinar is part of our Tech 101 series, where we present complex technological concepts as introductory webinars with a focus on their national security implications. As artificial intelligence continues to integrate into our national strategies and operations, ensuring its trustworthiness becomes paramount. Trustworthy AI is not just a technical requirement, it's a fundamental principle that governs the ethical, transparent, and reliable deployment of AI technologies in national security. These measures are critical in ensuring AI systems operate reliably and align with national security policy and objectives. How can we collectively build a future where AI not only enhances our defense capabilities, but also does so in a manner that is responsible and trustworthy? We will delve into this question during today's session. Now, some admin notes before we get started. All attendee lines are muted. If you have a question during the webinar, you can submit your question in the QA box in the webinar panel on the bottom right of your screen. You can submit questions during the presentation. We'll do our best to get through all the questions during the Q&A portion of our session. We are recording today's webinar for members unable to attend, and for any member who wishes to review the material at a later date. For the next few days, we'll also post the slides and recording to our website and YouTube channel. Now to introduce our guest. Dr. Matt Hale is a design researcher at the Software Engineering Institute at Carnegie Mellon University. His work focuses on enhancing human performance, system trustworthiness, and assessing user trust in AI and autonomous technologies. Prior to joining the SEI in 2023, Matt was a user experience researcher at iRobot, where he specialized in front-end innovation, competitive analysis, and usability in consumer robotics. Matt holds a dual PhD from Indiana University. Hello, Matt, how are you doing?
Doing good. Camera won't turn on. There we go. I'm good.
Oh, okay, there we go. Are you staying warm or cool in this hot day?
Yep, burning out time.
All right, well, good. It's a pleasure to meet you, and over to you for the presentation.
Sounds good. I have two monitors here, so I'm going to be looking to the left just for a second as I set up, but I will look at you in a moment. All right. This real quick. Are you folks on your end seeing the visuals?
Yes, I can see it.
Cool. It should say Trustworthy AI 101 and then today's date and a couple of other things. All right. So first, I'm going to show you the document markings. Hopefully you can see those. Those are part of our standard processes that we go through here at the SEI. So it's nice to digitally meet all of you. So I'm looking forward to speaking with you. Especially in the Q&A, I'm more of a dialogue rather than a monologue kind of person. But before I get started, I have some logistics. At least I hope these will align with what was just said. If not, A-okay. So I'm sharing my screen, and as a result, I've got some notes up in front of me. If there is anyone who's typed in a question and you submit it, if there's a question that's like relevant to the current context, whatever we're talking about, feel free to unmute and let me know. I'd love to talk about it, and that way I don't lose whatever that thought is in context or in situ. Anything that you want to say, let me know. If you want me to pause, if you want me to dig deeper into something, or if there's something that is maybe unclear, or maybe we'd be better served by focusing on a specific example. Maybe you disagree with something, and any of that. Feel free to unmute anytime or send along a question. Works great for me. I can't promise with that note that I'll be able to answer every single one of your questions. There's a lot of stuff emerging in this space all the time. I don't, I especially know the human factors side of things. Human subjects is my expertise. So you may ask me a question about the development of a model that I may not know the answer to, but I can connect you to someone who will know that answer. So saying all that, let me just preview the topics that I've laid out for us. All right, so first I'll tell you a bit about myself and for now. So we'll talk about the current moment in which we find ourselves trying to design and use and trust new technologies in both sort of the consumer space as individual citizens surrounded by consumption and products and services, but also in the context of the DoD and national intelligence and security. After that, I will provide a very light, super incomplete history of artificial intelligence as it relates specifically to trust. So there's a lot to cover. There's a lot more to unpack in the history of the emergence and the development of artificial intelligence technologies that we don't really have time to cover in this amount of time. And I am not a historian of artificial intelligence by any stretch of the imagination. So there would be a lot of stuff that I would gloss over. But we can glean some stuff by looking back at the past and how it informs the present. So this will be super high level with a fairly tight focus on trust and where it kind of fits into that equation, just to provide some context for what we're talking about. And then after that, we will shift over to talk about responsible AI. What is it? Why does it matter? And how one goes about designing, deploying, testing, evaluating, using, and maintaining AI systems in a responsible manner or responsible fashion. And then last, we will tighten our focus up a little bit more once more to focus on trust and trustworthiness, defining those two terms, both at kind of a high level and then thinking about them in real concrete practical terms as practice and not just as a set of kind of abstract principles. And I will say that that transition from theory or the abstract down to practice and application, it's really hard to navigate. That's what most of the work I've been doing here at the SCI and previously in my career has been trying to navigate. It's really hard to do. It's not super clearly defined, that pathway from theory to practice in terms of what we're trying to do with AI applications now. And there's not a lot of well-established precedent that one can emulate or critique or model yourself on. So that's kind of a quick preview. I'm gonna take a drink. So I'm going to introduce myself just a little bit, and there's going to be a reason I'm introducing myself because I'll compare it to something. All right, so I am Dr. Matthew Hale. I go by Matt. I am a design researcher at Carnegie Mellon University's Software Engineering Institute, or SEI for short. I'll be calling it that from henceforth. I have a dual PhD from Indiana University, and my background is primarily in critical media studies in anthropology. Throughout my career, so grad school, post-grad school, my research has primarily focused on how people understand and use technology in their daily lives, primarily on how they express themselves and how they monetize their hobbies or earn a living in sort of the digital attention economy. That's not directly focused on AI, though it kind of overlapped with. Later in life, I shifted into focusing in AI. So before joining the SEI last year, I worked at iRobot, which was previously mentioned. It's a consumer robotics company. If you've ever had a Roomba or you know the namesake Roomba, the brand, that's where I worked. And most of the work that I did there was focusing on front-end innovation, competitive analysis of looking at other systems, and then perceived intelligence, which I think is very relevant for today. How do people look at this technology, both the hardware and the software, and view it as intelligent or not intelligent? So that was related to usability, and particularly the application on the phone, the mobile device, and also autonomy as it relates to the dock that the device would go into and be charged by, and the hardware of the robot itself. So that's who I am, according to me. That's the story I told you about myself. I also asked ChatGPT to write a brief intro for me a couple of times just to see what the output would be. It's kind of a fun thing to do for yourself if you have kids, if you were thinking about a public sort of figure. It's just interesting to kind of prompt ChatGPT or any large language model and see what it comes up with, especially about yourself. And while it produced something that sounded very much like authentic human prose, if you read it out loud, it made sense. It was something that a reasonable human being might right. And you would probably believe, unless you scanned the QR code there on the screen and then kind of compare it to my credentials and background that's on LinkedIn, not that LinkedIn's real life. But it's just not true what it generated. It is wrong. It feels right. It's very believable. It passes the smell test, but it's incorrect. So the AI outputs require of any system some level of knowledge, experience, and expertise to evaluate their quality. So it's not like it can do everything for you. You still need some element of expertise. So I generated a few results. ChatGPT said I worked at Google. Nope, not right. Never worked there. That I got a degree from Harvard and MIT and a few other elite universities, all in the areas of computer science and specifically in artificial intelligence. Not true. It made me sound like I was someone who basically dedicated their entire life from birth to present to study artificial intelligence. And that's not the case. Now, the reason I mention this is because it allows us to look at how ChatGPT kind of described me as a particular case in point. But I also think my experience is pretty representative of how a lot of folks, possibly including many of you that are on the call or on the video, find yourself also, yourself in your professional life kind of coming into contact with and increasingly revolving around artificial intelligence. So you may have a background in computer science or some humanities or anything. Suddenly, you might find yourself needing to teach yourself about AI, how it works, detethering that from how it doesn't actually work. You have to wade through a lot of noise and some misinformation and speculation. There's a lot of guidance that exists out there, which is wonderful. But when there is a lot of it, it can be a bit overwhelming, and that can be a pain point. So the technology itself is also pretty opaque, which we'll talk about here in a second, and that can be a burden. So I asked ChatGPT then to explain how and why it generated those responses to my prompt, write a brief self-introduction for me, but it generated more text rather than answering my questions about explainability or reasoning and where it got its data. I could have provided it with more personal information, but again, that might give one pause. And it varies depending on context. Our trust is going to change. And it's not like I can build a comparable large language model. I don't have the hardware, the facilities, and most of all the data, let alone the experience, technical experience, to do that. But it's very, very difficult to build these kinds of ginormous systems. Well, that doesn't really matter that much for today. The risk of me misrepresenting myself in a presentation is pretty minimal. It's not life or death decision making like in a battlefield. That's not the case when we start thinking about DoD applications of artificial intelligence. So this brings me to the Software Engineering Institute. I'm a member of the Trust Lab, led by Carol Smith here at Carnegie Mellon. The SEI Trust Lab focuses on advancing responsive human-centered AI engineering practices through collaboration and research with DoD and industry partners. Our aim is to enhance human interactions with AI systems, develop frameworks, tools, guidelines to ensure mission success in DoD applications, integrating disciplines like responsible AI, human-computer interaction, and user experience. The strength of our team, I think, lies in our ability to leverage a diverse range of interdisciplinary backgrounds, experiences, and expertise, including but not limited to anthropology, that would be me, cognitive psychology, AI engineering, and interaction design. It's this breadth that allows us to approach AI development holistically, prioritizing human needs and interactions to create more effective, more responsible, and user-friendly AI systems that are worthy of trust and that people want to use. All right, so that's kind of the intro-y thing. I know that took a bit, but I wanted to tell you a bit about how ChatGPT decided to summarize my life incorrectly. So in Timothy Morton's book, Hyperobjects, I think it's from 2013, he wrote that modernity, so this is a quote, is the story of how oil got into everything. So if you want to conceptualize the 20th century as this instance in which oil kind of permeates all of human culture, I think we're seeing the same thing play out in real time as AI is being inserted, whether warranted or not, into just about every facet of our daily lives. And as artificial intelligence becomes increasingly prevalent across society, from healthcare to transportation to defense, obviously, ensuring its trustworthiness it's critical. AI systems reliability, transparency, and ethical considerations need to be rigorously addressed to foster trust and cautious and critical acceptance amongst users and stakeholders alike. Oftentimes, AI products and services are rushed to market, poorly thought out, they're unreliable, they oftentimes overpromise and then underdeliver. It's not good. Sometimes they get recalled or rolled back. The DoD is taking a measure twice, or I think you would say measure multiple times kind of cut once principle, if you want to use that adage, because the cost of getting this wrong is really, really high. It could be disastrous. It could be life or death. So it's better to do it right, measure multiple times, and do it the right way, as opposed to run fast and break things, which happens oftentimes in industry. So before we turn to the DoD, let's take a look at some recent examples of industry. So we're going to look at Google, Microsoft, and Apple. So let's start with Google. So they had bad outputs and that lowered trust. All right, so Google. So May 14, 2024, Google announces AI search overview at its I/O developer event, expanding on the previous search generative experience that they had. Over the next 2 weeks, AI overview rolls out to US audiences, and almost immediately users encounter problems. The outputs don't make sense. And some of those outputs are pretty problematic and they go viral on social media. By June 1, Google publicly pulls back AI overview. And as of June 15, so it could have updated since then, Google sort of reset and recalibrated expectations for users and reaffirmed its commitment to AI overview in the face of all these unexpected, incorrect, and untrustworthy outputs. So let's take a look at some of those outputs. I've organized them in a kind of like, it's not so bad to it gets much worse and has higher risk. So there's like 6 of them, so I'll show you. Number 1, how long ago was 1919? Got it wrong, not terribly detrimental to society or an individual. How many sisters do I have? This is an absurd response to that question that gives you this like complicated mathematical like algorithm to determine at any given moment how many sisters does one have. Bizarre, not terrible in terms of like its implications. Cheese not sticking to pizza. This is one of the examples that went very viral. It suggested eating 1/8 cup of non-toxic glue, but it is non-toxic. And then it gets more complicated. This one went viral because of it was directly referencing data from an Onion article, which suggested eating 1 or 2 rocks per day was recommended by geologists and health experts. Not true. Is it okay to leave a dog in a hot car? It suggests yes. Again, escalating severity. And then doctors recommend smoking 2 to 3 times a day during a pregnancy. Obviously, not a good recommendation. Obviously, not healthy. So these bad outputs directly reduce user trust in the system, thereby reducing adoption. Again, this is the commercial sector, but this matters for warfighter trust in the DoD. If soldiers are asked to test systems that fail to perform as expected, and they consistently produce ineffective, useless, or incorrect outputs, that's going to erode that trust. This matters both in terms of actually like fielding things, but also just doing testing and evaluation. We want to make sure that these systems are doing good work consistently, they're behaving as expected, and then we can do user testing with warfighters. So let's shift over to Microsoft real quick. So Microsoft has privacy concerns. Microsoft recall for Windows Copilot Plus computers was first announced in May 2024. It was originally going to be launching June 18. It was met with a wave of critical and concerned online discourse, especially amongst cybersecurity experts, but also consumers who were just concerned about data privacy and transparency of the system. By June 7, Microsoft rolls back some of these initial announcements in response to the consumer and expert reactions, stating that recall is just going to be turned off by default. And then a few days later, on June 13, so 5 days or something, like right before it was going to be launching, they roll back the announcement. They roll back AI recall. It's not going to ship on Windows Copilot Plus computers as it originally was intended. So AI recall, let me tell you about the tool. It's a tool that regularly takes screenshot of a user's computer, and it uses that to create a kind of photographic memory of every single piece of information or activity, on-screen activity that a user does, and then it is semantically indexing and stores that locally on a user's device. Storing it locally is good. But this immediately causes great concern about privacy. How is my data collected? How is it stored? How is it protected, if at all? How is it being used? Depending on your role and the work that you do, it's very likely that many of you wouldn't even be allowed to have this product or service anywhere near you or your work because it poses an enormous amount of like security threats for DoD militaristic intelligence space. Like you just could not use that. For applications with warfighters, we don't want them to feel unable to do their job effectively because they're maybe overloaded with information, but we especially don't want in the context of Microsoft here to feel as though that every action is being quantified and analyzed and that their personal data and privacy are out of their own individual control. That could prevent users from trusting in this, adopting maybe a drone for search and rescue or an intelligent mapping system or an autonomous ground robot, even though those technologies might solve specific problems or allow one to stay out of harm's way or to be more efficient. But if the trust isn't there because of privacy concerns, let alone bad outputs like the previous example, people aren't going to use it. So one more quick industry example, then we're going to shift to DoD completely. So on June 10, this was fairly close to when I started prepping for this, Apple announced Apple Intelligence AI at their Worldwide Developers Conference. I don't think Apple did everything right. I'm not trying to put them up as a paragon and contrast it with the previous two, but I do think they did some things right that it's worth taking some lessons from. So Apple Intelligence is this personalized AI tool. It understands and uses the context of each user's personal data and the activities across all of their applications. So it's not contained in one application, all their applications. And that is used then to enhance everyday tasks. And these can be pretty low stakes, like texting, writing an email, editing photos, making recommendations, any of those sort of daily tasks that you might do on your cell phone. Here's where they got things right. Besides the functionality, Apple promises that users' data is only used to fulfill requests and will never be stored or accessible to anyone, including Apple themselves. Their integrated chat GPT features are opt-in by default. Users are prompted before any data, so text, images, or any sort of files, is going to be sent over to chat GPT if they are using that integrated feature. Likewise, users' IP addresses will be obscured from OpenAI, and it won't store user requests. So in there, we'll see if they live up to their PR, their marketing, and what they said they were going to do. But let's say they do. Foregrounding users' rights to privacy led to generally favorable responses from audiences and experts alike. This kind of privacy-first, transparent rollout is worth learning from and adopting. And we can see a bunch of different examples from Adobe just rolled back a bunch of updates to their terms of service. McDonald's just removed automated chatbot-style ordering systems from like 100 plus locations throughout the US. So getting it wrong oftentimes costs more than just doing things responsibly from the ground up. So companies are so busy integrating AI functionality, building hype, especially around generative AI, Gen AI, and shoving AI into any and pretty much everything they can. They are, to quote Ian Malcolm from Jurassic Park, so preoccupied whether or not they could that they didn't really stop to think about if they should. Now, that's not to say that individual engineers or researchers, testers, QA specialists, et cetera, aren't trying to slow down and assess whether AI is the actual right tool for the job at work. But that profit motive and hype, that's a really strong driving force behind a lot of the AI kind of gold rush or boom that we're currently experiencing. And that social, cultural, and economic transformation in energy exerts force on the government and the DoD and just about all sectors of life. So if you've got time and if you're interested, like if this piques your interest at all, there YouTuber and tech reviewer Marquez Brownlee, I think it's MKBHD. He has a great YouTube channel. He's done a couple of things on like the AI humane pen, humane AI pen. Most recently, I think his most recent video was called AI the product versus AI the feature. It is very much worth watching, and it's very useful to think through in terms of trust and trustability and trustworthiness. So the history of artificial intelligence dates back to at least the mid-20th century with heroic wartime efforts by like Alan Turing, the Enigma machine, which led to his imitation game tests. And then subsequently, there were later works by John McCarthy, Nathaniel Rochester, and Claude Shannon, among others. They coined the term artificial intelligence in a research proposal for a workshop that would take place the following year. So from 1955, then the workshop followed. So we're going to jump. So now over a half century or so after that, artificial intelligence has advanced by leaps and bounds, but with rare exceptions, it doesn't really kind of bubble up to the public imagination, or hasn't all that much until recently, not directly. With a few exceptions. There are occasional things where it's like a John Henry, if you think about that story, like tale of a competition pitting world-class masters at some ability with machines. So there are a few examples: AlphaGo, chess, and checkers. In 1962, Arthur Samuel designed a computer that defeated a checkers champion. There was a similar thing with backgammon in 1997. IBM's Deep Blue was a chess program that bested the world champion at the time. So those kind of stories bubbled up to the surface, but it wasn't really part of the kind of the zeitgeist or the cultural imagination. It wasn't really something that people were thinking about particularly deeply. And as a result, they weren't thinking about how much they did or did not trust these systems. Now, despite significant advances in computational power and capabilities of AI systems and the widespread adoption of computers and algorithms and other digital technologies, trust has remained a fairly significant barrier and consistent to the adoption of artificial intelligence. This is rooted in fears about its reliability, the very real concerns about job loss, the loss of creativity, privacy issues, transparency, safety, complex, very complex ethical concerns. And although AI systems have become more sophisticated and widespread, building and maintaining trust has been and it's continued to be a fundamental and consistent barrier to adoption of AI technologies. So on the screen there, I'm going to highlight two specific examples in which trust pops up. So in 64 to 67, there's the ELIZA. It's kind of the first chatbot, if you want to think about it that way. It was developed by Joseph Weizenbaum. It was an early natural language processing tool. It simulated natural conversation and created the illusion of understanding. So as people would type into this interface, it would communicate back. Users attributed in understanding and intelligence and empathy to that system, and they gave it a lot more trust than was really warranted, which definitely disturbed Weizenbaum and others. And then another more recent example, though still been a bit, March 23 and 2016, Tay, a Twitter bot developed by Microsoft Corporation, was released. It was designed to engage with and learn from Twitter users. And Tay, if you remember, like quickly, almost immediately began generating very offensive content, demonstrating the risk of deploying AI without robust and appropriate safeguards in place. It was deactivated within 16 hours of launching. So again, measure multiple times, cut once. But a lot of this, the kind of current obsession and focus and work that's being done on artificial intelligence within the DoD, across the DoD, and outside of the DoD and just sort of like everyday life, is in response to sort of the emergence of large language models. So 2014 up to like 2020. So the rise of Gen AI and large language models in that time period, particularly following the release of ChatGPT, so OpenAI's ChatGPT 3 in November, it was like November 3 of 2020, kind of right in the middle of the COVID pandemic. That just captivated the public imagination, as you can see from these Google search terms. People were searching for artificial intelligence, but as you can see from AI, generative AI, Gen AI, which does make sense, large language models, and LLM, it just spikes right around the 2020 into the 22 era. And it's because it provided users, consumers, and everyone a look at unprecedented capabilities in natural language, understanding, and generation. And it kind of caught us all by storm. So when thinking about all this stuff, we have to think about designing, implementing systems, and testing them in ways that are responsible. So now we're going to define responsible AI. All right, so RAI, responsible AI or RAI, is an approach to developing, deploying, and maintaining AI systems that are safe and reliable and ethical. That's a lot. Like that's a lot to parse out. Making sure that a system is safe or reliable is complicated. The ethical consideration is extremely deep and can become really, really complicated challenges. Interesting challenge to focus on, but it's a hard challenge to endure and solve. The goal of our AI is to maximize positive impacts of a system while anticipating, preventing, and minimizing its potential negative social, political, economic, and environmental impacts on individuals, on populations, and society as a whole. So that is the larger umbrella term under which trustworthy AI and trust focus on trust in AI. So despite the hype AI is a tool. It's like any other. And like any tool, it can't really do everything. It can't be like you could build a home with a screwdriver exclusively, but it would be an unwise decision to do so. It would be inefficient and probably highly dangerous. Similar thing applies with AI. It has relative strengths and weaknesses, and we need to consider those when integrating, designing, and using those technologies. So as far as strengths, it can analyze large data sets quickly and accurately, way faster than any human being could ever possibly go through assortment of text. If you've ever written a master's thesis or a dissertation or a book or anything, the amount of volume and text that an LLM can parse, it boggles the mind, and it's very humbling. AI are also very good at automating repetitive tasks. If you're familiar with philosopher William Morris, useless toil, just kind of rote, continuous, repetitive tasks, very good at taking those over from human beings. It can recognize patterns and trends in large data sets, and it can generate insights fairly well and predictions based on data. Humans can do all of those things too, but the scale and speed is very, very different. Now, as far as weaknesses, AI struggle with contextual or situated reasoning. Nuanced ethical judgment is complex, and humans have a hard time with it, so it makes sense that AI do as well. Creativity and novel thinking, if you've ever played with ChatGPT or any of the kind of generative AI visualization tools, oftentimes it'll just produce stuff that looks like other stuff, especially other AI-generated art. It's hard to produce some new thought. It's also hard for human beings to produce new thoughts. It struggles with emotional intelligence, and especially with ambiguity, and ambiguity being a particular concern because if you're taking a robot out into the field for testing or it's in combat, that's a really complex, messy environment that changes all the time, and the system needs to be able to adapt on the fly and not be a problem and rather be a tool that is helpful. So considering those strengths and weaknesses, it's important to keep all of that in mind. So you might hear people talk about hallucinations. It's not a term I'm super happy with. I'm not the first person to say that. Lots of people say that. That is when AI generates incorrect or nonsensical information that appears plausible, but isn't really based on real data or facts or existing resources. A better term, at least for me, is confabulation. You'll hear people use that word to describe the process in which AI just sort of makes stuff up to fill gaps. If you ask an LLM to write you a 30-page report about international relations and armed conflict across Europe, plug in whatever thing that you want to talk about, let's say, and then specifically you request that that system provide you with citations to support any claims made in that document, it probably will, but without care or expertise or being very thoughtful, you might not realize that many, if not all of those resources of citations that the LLM spits out, so to speak, are totally bogus. They're just made up because it is not concerned with the truth. It's not concerned with a truth claim. It's just producing an output. So it's not the same thing. Those things aren't commensurate. There was a recent paper, I think it came out earlier this month, by Michael Town Hicks. It's awesome. James Humphrey and Joe Slater. It was just published. The title is ChatGPT is BS earlier this month, and it's well worth your time. And they're describing these processes in ways that are slightly different, calling it BS. And I think they make a good explanation of why they use that language rather than confabulation or hallucination, which can be confusing. And they say, quote, because these programs cannot themselves be concerned with truth, and because they are designed to produce text that looks truth apt without any actual concerns for truth, it seems appropriate to call their outputs BS. So the output of AI depends on data. Data is the bedrock upon which all AI is built. It's basically data, math, and some programming. So data is crucial. Your system outputs, whether it's a self-driving car, a facial recognition system, an autonomous military transport, or a note summarization tool, pick whatever you want. The outputs of a system are made possible and therefore influenced and also delimited by the data that goes into the system, from training to testing to its actual use. So data quality is paramount to producing high quality and reliable outputs. And again, if you don't have good data, or you have data with really significant biases, I'll talk more about that here in a second, you're going to get lower quality outputs, and consistent low quality outputs that don't measure up to what users expect is going to lead to lower adoption rates. And then you've wasted all this time, money, energy into producing a system that people aren't going to use. Now, the problem is, all data is biased. That is a fundamental assertion, but it is a problem. It's impossible to remove all bias. I mean, human beings are biased. So there is no instance in which there's like this pure instance where there is no bias at all. But it is a thing that we have to contend with data when we're building these systems. So if you were to implement a computer vision system for reconnaissance, and a key feature of that device is facial recognition, and let's say it recognizes faces and cross-references those with data in a database to identify people who've been previously, I don't know, identified as a terrorist or something like that. It would be really important to have a diverse data set of images that's actually representative of different kinds of people. You don't want to create unintended racial or cultural biases in that system. That will lead to not only bad outcomes in one sense, but bad outcomes in another. It's unethical performance, right? So you don't want bad outcomes in either of those two senses. So I've mentioned these two terms a couple of times. Let's define them and kind of detangle them a bit. So because oftentimes these two terms are used interchangeably, but for our purposes and for the purpose of designing responsible AI systems, we need to think about them with slightly more precision. So Gregory Bateson, an anthropologist and cyberneticist, talks about the difference that makes the difference. There's a meaningful contrast when placing these side by side, so that's what we're going to do. So trust is a psychological state based on expectation of the system's behavior, the confidence that the system is going to fulfill its promise to the user. I didn't graphically map this out, but if you envision a user and a system existing like side by side looking at one another, trust is oriented in the user. It's located in the user and oriented towards the system. Now, the flip side of that is trustworthiness. Trustworthiness is a property of that system, and it demonstrates that it's going to fulfill its promise by providing evidence that is dependable in the context of its use, and the end users have awareness of the system's capabilities during its use. So it is located in the system and oriented towards the user of the system. So no one comes to AI blank. They come with previous experiences and biases based upon those prior experiences that set or modulate their expectations. So you're kind of fighting an uphill battle if you're trying to start using these technologies in the DoD. So there are a lot of perceptions. Some of them are filtered through science fiction and marketing hype that often overpromise and underdeliver in an effort to kind of ensure short-term shareholder return. Technology itself, which we'll talk about more in a sec, is kind of a black box. It lacks explanation oftentimes. A warfighter can ask a teammate who they trust to provide reasoning behind why they made a particular decision, for example. But a robotic battle buddy can't do that, or at least it would be ideal that it could, but oftentimes it can't. And users might need that information and capability to actually trust the system, because otherwise it might make a decision or fall over or do something silly. And you're left with, how do I interpret this? Why did it do that? What are the choices that it just made, and what are the motives behind that? And then finally, the complicated uses. So people have access to AI tools. They use them in interesting ways and complicated ways. So perceptions filtered through science fiction since at least the 19th century, Mary Shelley, Creature and Frankenstein, all up through the golden era of sci-fi, the pulp adventures of the 20s, the 40s and 50s, at the same time that Alan Turing is working, especially the work of Isaac Asimov. We have popular film from the 60s and 70s, Star Wars, Star Trek, HAL 9000, and Stanley Kubrick's 2001 Space Odyssey, all the way up to Spike Jonze's film from 2013, I believe, called Her. All of these things shape how people approach the technology. It's a kind of lens by which they view these technologies through these prior experiences. And representations of intelligent machines or devices, autonoma, thinking computers have existed, throughout science fiction, and that shapes how we think about these technologies. There's also marketing hype by just about every corporation pushing AI as a product or a feature. And oftentimes representations of AI capabilities far exceed the actual grasp of what it's capable of doing. If you've got your computer handy anytime, just Google AI and select images. It's nothing but kind of samey. It's very similar looking imagery with kind of neon smooth features, oftentimes depicting a robot thinking or a brain, which makes sense because they're thinking about robotics and autonomous systems and neural networks, but it doesn't link up with reality. And that shapes how we think about these things. The other thing that people come to AI with is this black box conception. So AI systems are often referred to as black boxes due to their lack of transparency and explainability. Users often don't know anything about how, if at all, their data is being used, what data a model was trained on. There's little or no explanation as to how or why a system generated a particular output. This opacity makes it difficult for users to understand how an AI model made decisions, which in turn directly impacts trust. When users can't see or understand the reasoning behind an AI's output, they're in general less likely to rely on or accept its recommendations, or the exact flip side of that is they might just accept false, unfair, biased, or just plain wrong outputs, recommendations without any sort of questioning or critical thinking. They may just go, okay, that's what the model generated. This is an area of expertise that I don't have. Here's this information. Let me see what it says. Okay, great. I'll just use that. So this lack of clarity is extremely problematic in critical applications like healthcare and finance and military and intelligence applications, where understanding the decision-making process, just not what was done, but how and why it was done, is essential. Improving AI transparency and explainability is crucial for building systems that are worthy of user trust, and that will thereby lead to improved user trust and adoption of these technologies. All right, so last, there's complicated uses of AI. Trust in AI technologies is compromised in a number of ways by the fact that we're constantly bombarded with AI-generated images, deepfakes, content that is fake but is presented as real, AI song covers from Plankton or Mr. Krabs and other characters from SpongeBob SquarePants. So while much of this AI-generated content, particularly what I just listed, is pretty harmless, a lot of it is not harmless. One case in point was the pornographic content that was generated of images of public figures. I'm thinking particularly of Taylor Swift in January, like early January of 2024. There was a whole lot of content that was produced, and it was really problematic and gives rise to new needs for new policy and new legal structures. Another thing that can happen, making political figures say and do things that they never said or did. You can use software to create digital avatar clones of people, imitate their voice, make them say or do just about anything. And while many people might question these outputs, there's no guarantee, not at least now. Sometimes they lack traceability. It doesn't guarantee that the wheat is going to be separated from the chaff. And that erodes trust in AI as we're exposed to fake content, not to mention concerns that AI is going to automate tasks and replace workers and compete or outright replace artists or creatives or other things. So trust, people come to AI, they're not blank. They have perceptions and opinions and fears and concerns, and those are all very valid. Trust is dynamic. It's earned through consistently and continually producing high quality results. Now, systems aren't perfect. They have problems. They might produce low quality results, face uncertainty when classifying maybe an object or making recommendations or generating new text or images. They fail. And it's important that when that happens, the devices, just like you would expect a coworker or a teammate, particularly for a warfighter, to be able to communicate this to users or to others in a way that's clear, legible, and ideally actionable. Trust isn't really a rigid binary. One's either 100% trustworthy or 100% doesn't trust AI-enabled systems across the board. Rather, trust, certainty, confidence, whatever discourse, whatever language one wants to use, an engineer might describe, or what we might employ to describe or think about trust, it's often mapped onto something, specific capability, a subsystem, a particular use case or context, a task, or the possible or anticipated risks and harms relative to the potential benefits one might gain from using that technology. It's not, I don't trust AI as much as I don't trust this device or this system to do this task in this context, but a user might be willing to outsource certain maybe low risk, low skill, oftentimes repetitive tasks of their labor to these systems, thereby freeing up their time and attention and expertise for tasks that demand it. So our goal is not, in doing responsible AI with a focus on trustworthy AI, it's not to achieve 100% user trust in a system. Not even saying that's possible, but that is not what we want. Trust, like so much in life, is on a continuum. So on one end, we have distrust, where the trust by the user or the human being is less than the system capabilities. And this oftentimes leads to disuse. I wrote a note to myself, it's like me using Siri while driving. It constantly fails me, and as a result, I do not trust that. I'd like to. Then on the other hand, we have overtrust, which I was kind of describing earlier, where someone's trust is above the actual system capabilities. And this may lead to misuse. If think about Eliza that I mentioned earlier, thinking that it's capable of doing things like understanding and empathizing with the user, it's not doing that. It's just producing results based on an algorithm, and the human beings then kind of projecting, anthropomorphizing that system. That could be problematic. So what we want to do, our goal as human-centered AI researchers and designers, is to encourage, not to direct or to coerce or dupe users into trusting a system. We want to build systems that are deserving of a user's trust, and we want the user to arrive at and to kind of inhabit a state of calibrated trust as appropriate. Another way of thinking about it is like an appropriate level of skepticism towards technology. This is sometimes referred to as justified confidence. That is to say, to quote the National Security Commission on Artificial Intelligence's 2021 final report of artificial intelligence, quote, having justified confidence in AI systems requires assurances that they are to perform as intended, including when interacting with humans and other systems, end quote. To arrive at justified confidence or calibrated trust, we need to consider and create thoughtfully consider and thoughtfully integrate software, hardware, data, computing, communication, and then the human that's using the system. So I'm just going to leave this here. So trustworthy systems need to do these things. They need to adhere and uphold AI's ethical principles, utilize and protect data appropriately, augment and supplement rather than replace human capabilities, consistently provide relevant system status to users, have explainability and transparency built in. It needs to be trustworthy by design, and it needs to offer opportunities to collect user feedback for continuous feedback improvement over the lifetime. So this is a list of US guidance policy law. It's obviously not exhaustive. There's a lot I left out, but I think what this shows here, since so much of it is from 2020 onward, is that the DoD and the federal government is putting a lot of time and energy into getting AI right from the start. The October executive, I think it was October 30, safe, secure, trustworthy development and use of AI, for instance, it's one of the longest executive orders in history. It outlines a timeline for actions across the government, placing a lot of emphasis on education, workforce development, the future of work, designing ethical, reliable, and safe systems. We have DoD Directive 3000.09 that came out just before the NIST RMF. It gives policy and guidance on how to review and deal with potentially lethal autonomous systems. In February 2020, probably the biggest thing other than the executive order, the Department of Defense released 5 ethical principles for adoption and use of AI technologies, guidance and principles for the acceleration and adoption of AI. So if you are in the DoD, you have to make sure whatever systems that you're using or developing, if you're integrating an existing product, they have to align with these 5 things. They have to be responsible, equitable, traceable, reliable, and governable. And it provides some outline. There are other things that one should look at. So in addition to those DoD principles, there's the NIST RMF. They provide, I believe, 7, though there are some with conjunctions in between, so you could articulate it as being more than 7. Things that one must do to have a trustworthy AI system. You can also look at industry for parallels. IBM has 5 pillars, including those things there. Deloitte has 6. The problem with these, there's also the European Commission's high-level expert group on AI. In 2019, they had a list of 3 things that a system must do to be trustworthy. I think it was lawful, ethical, and robust. But the complicated thing is there's a lot of guidance, and a lot of times the guidance is a list of adjectives or characteristics that one needs to adhere to or build into their system. So if you were designing or building an AI system in the work that you're doing, I would highly recommend that you not only just check out the risk management framework from NIST, but you also look at the playbook. It's most directly, I would say, practical and actionable for your projects and thinking through complex design decisions. In addition to that, I think it's extremely important to do user research so that you're not just focusing at it, working on this problem as a system down, but you're also looking at it from perspective of the users. You need to understand what users of your system, what are their trust requirements, what is the context of operation which they're going to be using that system, what are their pain points, what are their top concerns, what is it going into using this technology that they need to know, what information is relevant to them for them to make good quality decisions. So if you have a chance, and you haven't already, check out the risk management framework as well as the playbook. How am I doing on time? I see there are 3 questions. I'm going to take a drink. I think I'm like right at time.
Yeah, we're right. We're getting close to out of time for us to go through the questions.
Okay, I'm going to show 3 images, and we can just talk about them if folks want to here in a sec. So from theory to practice, I brought up just 3 examples. So using a large language model in the context of an intelligence task for the DoD, the risk profile for this could vary significantly. There are lots of trust and RAI concerns, which I think this works better as a conversation than just reading at someone. The use of autonomous technologies, so AI-enabled intelligent vehicles, be used for military applications, logistics, transportation. It can be used for warfighters, government officials, you name it. What happens if something goes wrong? What happens if there's an update while all these vehicles are on the road? What, like there's a lot to think through and parse and try to solve. And then the area that I am personally most interested in is using AI technologies to kind of supplement and augment warfighter capabilities. So their existing capabilities, how can you elevate that or supplement it with information and communication technologies, improving both sort of strategic level and tactical level real-time decision-making. So I will stop sharing screen since we're at time. Does that sound good?
Okay, so I guess we're in the Q&A portion. So the first question is from Charles. When this is going back to your bio check on GPT, I believe it was GPT. The question is, were you using the full version of GPT 4.0 when you ask those questions? And I guess a corollary question would be, are they, for like GPT, are there different levels of accuracy in these large language models? For example, if you get the free version, you have a different reliability as opposed to if you use the paid version.
That's a really good question. I think accuracy and performance is frequently hidden behind paywalls, so that the better performance, the better accuracy, more correct responses oftentimes probably is hidden behind paywalls. I don't have data to say, yes, I've tested this, and out of 3,000 attempts, the data for one was better than the data for the non-paid versus the paid version. I was testing it both with 4.0 and 3.5. Interestingly enough, I wasn't logged into my personal account, which is a paid account. I was just doing it on a random device at my house, and I hadn't logged in. And halfway through it, it alerted me that I've run out of the ability to use 4.0 because of, hey, you've encountered the cap for what you can do free. Now you're going to 3.5. I didn't really notice a difference between the two, but neither one of them new information about me personally. I think the most recent update, the last time I checked, if you ever ask ChatGPT or any large language model, this is a significant problem, is there is a point at which they haven't been trained further. So if you're asking about very contemporary, like open it and ask it to describe a contemporary popular trend on like TikTok or something that's very ephemeral and just very recent, it won't be able to say anything about it that has high confidence or is accurate because it's not trained up to that. Anyway, that was a long-winded answer. It was with 4.0 and then 3, and I did notice a huge performance difference. And I think a lot of the models are currently focused on performance. I'm interested to see what happens in the next like decade or so. I think performance is still going to be important, but then maybe efficiency, because these things use a lot of power. I'm really concerned about the environmental impact of AI technologies.
The next question comes from Steve Greggs. The question is, the web and software industry has a velocity of releasing minimal viable products. Well, AI releases as minimally viable products do they instill trust? What happens when there's damage is done? Is it hard to recover? How would you convince a minimally viable culture not do we want them done for decades?
Mm-hmm. I think for a parallel, like video game culture, I'm a person who plays a lot of video games. And I think in that space, very similar to kind of the general trend in technology, like the tech sector, there is a trend towards releasing more and more broken products or products that aren't completely fully baked by the time they reach the consumer. And the idea is that, hey, you've purchased into this like lifestyle brand product. We promise we'll finish it. And that's really not acceptable. So if you buy a video game and it's completely broken, and then 7 months later, it's like an appropriate level of you can enjoy it and play it, like Cyberpunk 2077's or No Man's Sky are good examples to think about. I think it's really dangerous with large language models or any generative AI technology, because it's not like a video game. A video game has a kind of boundedness. It's contained. You go into this world, you play a video game, you might interact with other people in a social environment online, but you're not using it as a source of truth to generate information or knowledge. You're not using it if you're a student to generate your college paper. So like you might go on Call of Duty and play a game and it's a little busted, and then you leave and okay, you've exited that world and you're back into the quote unquote real world. With kind of broken, incomplete, incoherent models, I think that's problematic. The outputs, if taken with too much trust, could be dangerous. But even a fully functioning, like great product, there is randomness. We don't know exactly what the output of a system. As I just ask it to describe me, I did it like 5 or 10 different times, and it produced different things each time. So there's a kind of randomness factor, unpredictability built in there. So even on the best of conditions, it can still be problematic, or is problematic.
A question from Quang Long. Is there any way to improve transparency or explainability of deep learning black box models?
I have friends and colleagues here at the SEI and a couple of startups who are working on this problem. They're finding it really, how to say, they're developing tools and best practices, but thus far I think it is necessary, but currently what is available is insufficient, if that makes sense. Like, this is work we need to be doing. We're not there yet. And it's extremely frustrating to generate content of some sort, let's say text, and then not being able to interrogate or understand what were the various decision makers, like what were the weights that were used in that system that you arrived at this conclusion or this output or this recommendation. I would like to see, in conjunction with explainability, or like, I'm really passionate about user interfaces and interaction design, being able to make a system that would allow one to, almost like a tooltip, be able to look at a prompt, or not a prompt, but an output from a prompt, and to be able to hover over it and kind of parse, like, where did this kind of come from? But the complexity is, I don't know, with these giant models, there's no incentive necessarily, other than PR, for these large companies who are making marketing and selling these products to consumers, to kind of expose data to them or tell them too much about the means by which they're trained. ChatGPT 5, which is obviously not released, one of the folks who work there just recently, this has been kind of blowing up on LinkedIn, has talked about ChatGPT 5 is going to have like PhD level intelligence about specific niche areas. I don't know how that will operate, but I could believe it. And especially if you have different models for like different niche subjects. So like if someone's like, I have a model that's based on an expert on 18th century folklore in Europe, like, okay, that's really interesting. I can ask it anything. But what's it trained on? Like, I don't have any information about it. So I don't think I don't think companies are doing responsible AI the way the government, the DoD is doing it, which is, it's a principle first kind of activity, rather than, I think oftentimes industry is doing it as a kind of PR thing. I do believe people in these companies believe deeply in making trustworthy systems, understanding users' trust requirements, implementing that, turning those into system requirements, and then like building systems that are good. But at the end of the day, those are enterprises that are first and foremost focused on generating profit. And I can't fault them for that, but I do believe that responsible AI is oftentimes in the industry sector a tool for PR. Just like the Microsoft and Google instances, I think AI or Apple Intelligence, I think they are doing PR. Whether they actually come through and deliver, I don't know, but that's PR. I don't know if that answered the question, but it's a thing I'm very concerned with and interested in. And I don't have any answers.
Okay, one last question. You talked about the different, I guess, regulatory frameworks within the country. Have other countries come up with their own regulatory frameworks for AI? And how does that compare? Are they looking at being more restrictive than the US, especially Europe?
There are more restrictions, I would assume, because of the GDPR. I would assume, like, checking it side by side, like the EU AI Act is more restrictive than the United States, but I don't remember. It's been a bit since I looked at it. I was in DC when it came out and looked at it and was like, oh, very interesting. I will plug a tool. I'm in no way affiliated with it, but there's an AI, global, like AI, international AI policy tracker that is really fascinating to kind of scroll through, because every single country in the world is dealing with this new technology that in some ways is just a new tool, but in other ways is kind of very different and kind of scary and very fast. And they're all trying to grapple with, what are the guardrails and safety practices or procedures that we need? I feel like a lot of different, like we have OSHA now. If I leave my building, there are tons of things that I will walk past that are kind of invisible to me because they are so part of my everyday life. But just like a rail on the side of a staircase as I descend, there are laws and regulations and people in OSHA who care very deeply about those things, and there are codes and those things are enforced. I think we're going to have a kind of AI OSHA at some point. So like 10, 15 years from now, we'll have answers to these things, but it's in the messy middle right now where we're trying to figure it out. And so each country is generating lists. Oftentimes those lists are adjectives, sometimes nouns. And I think as a person trying to design or study or test and evaluate and validate all these systems, it's a little difficult with all of these different guidelines, oftentimes being lists, like here are the 10 things you need to do, but they're not specific. Like here are the metrics you need to have, here are the tests you need to run. More of, it needs to be reliable. What does that mean? Well, here's what it means in text. Well, what does that mean in terms of like performance metrics, or like how many user tests do I need? Is there like a good way to measure trust of a user? And if I get a benchmark, how do I compare it over time? Everybody's doing different things in different countries and different places. Here at SEI, we're doing a lot of different work on that, and it's really hard. It's very, very difficult. But it's super interesting. If you've not seen the AI policy tracker, Google it. It's really awesome. It's very useful.
That's great advice. And Matt, thank you for the time to inform our membership about Trusted AI. And that concludes our presentation for today. Thank you for your attendance, everybody, and the great questions. We'll post it, and also we didn't get through all the questions, so we will answer the questions and will be part of the post-production upload of this Tech 101. So in addition to that, we'll post online as soon as possible. If you have feedback about this event, especially topics you would like to see us cover in the future, please email us at eti@ndia.org. That is eti@ndia.org. I want to take just a few more minutes here to explain to you some opportunities to highlight that ETI is coming up with here in the near future, especially the second NDIA Emerging Technologies Conference that's going to happen August 7th to the 9th at the Washington, D.C. Convention Center. Confirmed speakers include Deputy Secretary of Defense Kathleen Hicks, Vice Chair of the Joint Chiefs of Staff, Admiral Grady, DIU Director Doug Beck, and Undersecretaries of Defense Hsu and LaPlante. Last year's event was sold out. Registrations, exhibits, and sponsorships. Information about these opportunities, plus opportunities to present some of your technical work, can be found at ndiatechexpo.org. That's ndiatechexpo.org. Or you can scan the QR code that you see on your screen. The next Tech 101 will be in September. So be on the lookout on NDIA's website, calendar events, for more information on September and subsequent Tech 101s. We also have some podcasts that are out there. More recently, we had a pre-meeting of the NDIA Emerging Technology Conference with Undersecretary Hsu. We also have a podcast on reshaping energy generation and distribution through power beaming. So take a look at those. Upcoming podcasts, we will have a podcast on vital signs, about the vital signs report, and also one about drone swarms. To register for these and other ETI events, please visit https://www.ndia.org/events. Thanks again for joining us today, and have a great day.